And then after the lesson, when you look at the meme that's on my jag,
you think I'll laugh?
it'll make
Is it the
probably not, but
probably,
it made me giggle.
Can you show it to us?
Okay.
The other day, I laughed very hard.
I did leave my notes back in that room.
Okay.
River's the kind of laugh.
Wait, Miss Casey, can you please give me
No,
one
not
moment to find my
usually
notes
math,
back
more
in?
science.
Well, then, I think it's Monday. What's it say on there?
11 to 4.
Oh, yeah, Monday. Surprise. Okay. Improper integrals. Okay, so improper integrals will have limits where, or integrals, I should say, where the upper bound, the lower bound, or both bounds are infinity or negative infinity. Okay? So remember, integrals are limits. So for proper notation, we're not going to plug in infinity. Okay? Some people will learn like a shortcut and they'll like literally plug it in. We're not going to do that because they don't like to see that on the AP exam. Okay? So we're going to basically introduce another variable, evaluate the integral, and then evaluate the limit.
Oh, wow.
Okay? That's all. So same thing here, right? So if we have negative infinity to b, we'll introduce a as our lower limit of integration.
So this is where you like really get going into the calculus.
Yes, this is the fun stuff.
Into the calculus.
And then what if we have from negative infinity to infinity? Well, we have to rewrite two parts, right? So we want to divide it up. That C value can be anything, okay?
And then do we have to do the same thing we did in the previous example?
Yeah.
Could we use 0? Can you scroll back up for 2 seconds?
You can use 0 as long as it's defined at 0. I would assume it is if that's the domain that they give us.
What are you supposed to do if you have a
Discard.
Yes.
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 Is the answer yes? I think so.
If you just turn the page, we'll do that as well. So we also will evaluate improper integrals when you have a vertical asymptote. Same idea. Okay? All right. So if the limit is finite, then that integral converges. Okay? And that is the value of the integral. Whereas if the limit fails to exist, we say that the integral
So it
diverges.
has infinite area.
Yes.
Is it no? Could we?
No, it could be most times yes.
Okay.
Well,
Okay.
what's
I
the
like that
exception?
answer.
Because we do know that there are some weird, there are,
Sign.
I don't want to say always, because there are some really weird functions out there that you may not have, like something that oscillates, for example, it might not necessarily have an infinite region, but it's not converging on one value.
Oh, like between the
Oh.
So does that
Okay.
make sense? Like it's flip-flopping, just like when we looked at the sequences that were flip-flopping.
Like,
So like at a certain value, it might be an area, another value, it could be another area. But as we approach infinity, it might not be approaching one particular
Two
value.
different-
like negative
and it's not
possibilities.
necessarily approaching infinity either.
Like negative
You know,
1
does
to
that make
the
sense?
negative 1 times and
Yeah.
negative 1 to the power of n.
Why did we learn? I was curious. Why did we learn sequences like in this chapter? Like, what does that have to apply to the rest?
Because next chapter, we're going to do series. And what we do with sequences will lead to what you will apply with series, like geometric, like all those rules that apply to sequences will also apply to series later on. So series are basically taking your sequence and adding all the terms. Okay, so the stuff that we did with sequences, it's not irrelevant. It's all going to apply to when we do series next chapter. Okay. What?
Explanations?
That's what the series.
Like
Series is a sum.
It's factorials. Kind of.
It's
Maybe
Taylor.
it's similar to factorials.
Not all of them have factorials. in them.
Factorials are utilized.
Okay, stop asking so many. Okay, no, I love these questions. I'm sorry. Happy to answer them, but it's just, procrastinating.
This is your favorite.
Okay, so if in part 3, just so you can see, part 3 has 2. So basically it's saying if both of these improper integrals converge, then the whole thing converges, right? Otherwise, it's going to diverge. So both parts have to converge, And if one part converges and the other part diverges, then the whole thing diverges.
There are examples of functions that have the limits from negative infinity to infinity, and their integral does not equal infinity.
Wait, say that one more time.
There are integrals with limits from negative infinity to infinity that don't result in the area being infinity.
Yes. Now, if we look at this first example, hopefully you can make a prediction whether this is going to converge or diverge.
Is it in terms of something when you do this? Like when you
Because
do
if- What do you mean?
like when you do the limits and everything, is it in terms of something, or is it just like how would it not be infinite?
This is going to be infinity.
Okay, this one's going to diverge. Okay, it's e to the x. I want to give you some examples of both. Sometimes we can make a prediction, e to the x. That's an exponential function. There is no upper bound, right?
We'll just go with
So we should get something that diverges, but sometimes we don't get something that's going to be as obvious, okay? And also a lot of the stuff that we're going to do in this section will directly apply to also when we do series in the next chapter. So the first thing we want to do is we want to express the improper integral as a limit of definite integrals. Okay. Yes.
How could this even be? Like, how could this even be finite? If it's
So were you listening to what I said?
Oh my god, I hate you so much.
Yeah.
So e to the x is e to the negative x squared.
Well, we're going to get to some more examples. Okay.
It's root prime.
All right, here we go. So the first thing I want to do is I want to divide it up into two parts. So I already addressed that. You were listening. Okay. We want to first express the improper integral as a limit as definite integrals, meaning that's where we want to replace our negative infinity and our infinity with some variable.
Because
I'm
they
using A and B. You can use any letter you want.
They don't count the
Don't
top
use
one for the
X.
AP test, only the bottom one. Because you can't have.
Well, remember, so if you go back to what we wrote up here, where I said introduce another number C. C can be anything as long as it's in the domain of the function. It's e to the x, so the domain is all reals. I use 0. I could have used 1.
Why is
Could
it-
have used
why is
1,000.
it
Could use
these?
2.
Okay, so I have
Can you
e,
zoom in a little bit, please? A little bit. Thank you.
and then I'm going to rewrite this one. Oops.
Why'd you go to 0? Or is that
Check.
B approaches infinity from 0 to B. Okay. So again, we're going to leave that limit out in front for right now. This one, again, hopefully we can predict what's going to happen, but let's just make sure we can prove that. So when we split it up into two parts, either we want both of these to diverge or one to diverge. That's what we're anticipating. Okay.
I think one's going to diverge.
One's definitely going to
I don't know about
diverge.
the other one because it's 13.
So let's see. What do we get?
One.
E to the x from a to 0, right? And then we have, oh, that is not a nice.
It's right, it doesn't go from-
So e to the x. All right.
That's also negative. This one's also negative.
No, sorry. Okay. There we go.
Good catch, though.
This one's negative 50. All right. Now we want to plug in e to the 0 minus e to the a, right? This
we
one will
plug
be...
it in? No.
Right, so we want to evaluate our limits of integration, and then the very last thing, this is where we're going to do the limit. So I know it's a little bit tedious to keep writing that limit way back when you were in pre-calc, and you had to rewrite the limit over and over again, but technically that's what we need, okay?
We still have to do that.
It's 1 plus infinity.
What's 1 plus infinity, Tyler?
I never wrote the word.
Infinity
So-
plus 1.
Well, the first one is
Oh,
negative
you-
infinity.
Okay, so the first one's going to end up giving us 1, right?
Why is it 1?
E to the 0 is 1. Well, what's going to happen with this one? This is going to become
E to the infinity would be-
0
Oh,
because this is limit as a approaches negative infinity.
I'm just gonna go really.
So it's going to be really, really small. So that's going to be 1. Right? So technically that's a 1 minus 0. However,
This is gonna be infinity.
this is going to be an infinity minus a 1. Right?
Infinity.
Infinity.
So this diverges. Therefore, right, this integral diverges. So I said if one part diverges,
The whole thing.
the whole thing diverges. Okay.
He's doing it because Owen told him that.
And then if it wasn't okay, so if it didn't.
So now
diverge-
imagine if we did have the integral from negative infinity to 0.
then it converges on the limit, right? It would
That'll go to
converge on that
1.
limit.
Good.
Wait.
Wait.
Very good.
I'm very good.
Oh, I have a question about.
Yeah.
This infinity starts at anything above 0, right? Positive infinity, or is it also? Is it all real number? Sorry, it's all real. I just ignore I said that. I'm
It's so
I'm going to try to ignore it, but it's kind of hard. Okay.
215 frames.
Goes on YouTube.
It just goes up.
Can we make
forever.
you an intro video like this? Movie?
sure.
Would you really not mind?
Make sure you include a disclaimer. Okay.
None of these videos are going to be helpful at all.
Every time I watch this.
I do not condone.
You can like hear my
Guys,
voice
can
in
you
the back.
can you-
Imagine me.
You can go
Okay.
back to like freshman year and like.
Let's
hear
go.
me talking in the back.
Limit as b approaches infinity of what?
Of
That's
Natural log of x.
general.
I want to x from b to 1.
It's like, no.
Mhm.
1 to b. So this limit at the end.
So natural log of b minus natural log of 1.
Natural log was 1 and 0. Right?
Yeah, that goes to 0, but this goes to
Infinity.
Infinity.
I guess it could go to infinity. Yeah. I guess if you really wanted to make it do it.
Wait, you're
What's
saying
ln of infinity?
Yay.
Bro, please never ask me.
Okay,
No.
Is
that
ln
was
of
the
infinity
one I
infinity?
said. In this case,
Is
Yes.
ln of infinity
so
infinity?
you're saying
What's one
if I
plus
have
infinity?
1 over
yeah.
1000x, I'll still diverge.
You're trying to fit it
Isn't
in.
that crazy?
It is crazy. So the lower limit of integration, does it make any difference here at all?
Any.
Well, if it was 0.
No, I'm not. If I change this to 100, does that make any difference?
No, it's still infinity. It's still diverse.
I wanted you.
Unless
so
unless
bad.
the bottom limit was also infinity, in which case it would be 0.
Okay, let's try the next one.
I think it would be, right? There's the same limit. There's the rule of
Should
calculus.
we pull out the 3?
Yeah, you can move the 3 to the front.
Integral from 3 to 3.
You want to do that?
Does it really do anything?
Infinity to infinity.
Is that a better idea?
Not at all. That's actually what I did.
Wait, do we have to do the thing with the
Ask your mom right now.
Miss Cases?
Wait, what's that?
Partial fraction decomposition.
You can put a constant outside of a limit. Okay. Thank you.
You can also take the sign out or
Who
the log
discovers
out.
residential things?
People have too much.
That was useful.
This case
Yeah.
is the limit from infinity to, or sorry, the integral from infinity to infinity of any function is 0.
I don't think it is.
Just like how integral from 1 to 1 of any function is 0.
Wait, why are we?
Why would you ask?
Filming us.
Why would I ask that?
No. Yeah, no one would ask a question like that.
Okay.
You're unique.
God, what a great answer. Adam, that's such a stupid question. I don't think I've ever heard that
So-
one in my whole entire career.
So, Adam, you wouldn't ask a question like that because the rules for limits are based on real value limits of integration. So when we do the limits of integration, we say from A to A. The very first thing that we say is that A is a real number.
Yeah.
So we don't ask the question about infinity to infinity because infinity is not a real number. So the rules of limits don't work the same way. Okay, here we go. We want A over X plus B over X minus 1.
Oh my god.
Oh.
Oh my god.
Oh my god, are you kidding me? Oh my god.
Okay, you guys are really
Freebie.
ruining it for me.
Guys,
Okay.
This is one time a year.
Shut up.
I feel blazing.
Okay, so
I don't know.
what does A equal? What does B
A
equal?
times X minus 1.
Okay, guys, you can do this in your head.
Yeah,
When X
equals
is
negative
1,
clearly
B.
can.
A is 1.
Okay.
A is negative.
You think A is one?
When X is 1,
I know A is
B is
negative
1.
I know that A is negative.
When
1.
X is 0,
B is negative.
Negative 1.
A is
A is negative 1.
Negative 1. A's
A is negative 1.
okay.
I would agree with that.
Whew.
negative 1.
You give permission.
All right, so okay, so we want negative 1 over X plus 1 over X minus 1. Oh, I forgot my.
You didn't do the integral.
Oh, if you did, it just kind of looks
Okay, so 3 limit B goes to infinity. Okay, so now we're going to evaluate. So that's going to be negative natural log of X. I don't bother putting any absolute value because our limits of integration are all positive. So
And then plus ln of x.
plus natural log of X minus 1
I believe this also.
from 2 to B. Okay.
I believe we got a test where we had to use the absolute value brackets in using ln after we took the integral, because I don't remember ever having to do that. I always remember forgetting about the absolute value brackets.
Most of the time we don't need the absolute value because when we know what the limits of integration are, listen, if this said like it's not that we can't evaluate this for negative values. This function, the original function is valid, but I just eliminate them right to begin with based on whatever limits of integration we have.
You also have finals with like pieces.
So we have natural log of B. Oops, why did I do that? Plus natural log of B minus 1, right?
Minus.
And then minus, and then I have negative natural log of 2 minus natural log of 1.
Wait, can you reorganize that?
I'm going to reorganize that for sure.
Wait, can you
How would we reorganize that?
ln of 2
we can
minus
use some of the
2.
rules that we know about natural
Yes.
logs.
So the first one, I'm going to rewrite this as natural log of B minus 1 over B.
Times
Where'd you get that?
2.
You know where you got that.
Well, plus ln of 2.
What
Plus
happens-
natural log of 2. Good.
What happens to the negative?
It becomes subtraction, which becomes division.
Oh, it becomes. Okay.
Yeah, so don't forget all those natural, because then we had something like this on the, was it the quiz or the practice quiz? I don't remember, where there was like a limit with a natural log or something like that. So we can move that natural log to the front, it's a function,
So it's
and just evaluate, or we could think of what's the limit as B goes to infinity? 1. So what's going to happen with this whole thing here?
So then it's just ln.
So this is going to go to 0.
Wait, why?
Because it's
It's gonna be ln of
infinity over
1.
infinity.
It's gonna be ln of 1, which is 0.
You're correct.
It's-
That
You
is
only
one.
look at the big. You look at the biggest term. The biggest term.
I'm looking at the big picture.
It has the same degree of coefficients on top and bottom.
You
That
look
whole
at the
thing goes
big
to
picture.
because the inside turns to 1. Jack was right.
Yeah.
You're so wrong. It's crazy how wrong you are.
3 ln of 2.
You upset? You mad, bro?
Okay.
You mad?
This shocks me that it converges. I was looking at this the whole time.
It didn't shock me at all. I was actually pretty sure it would
If you see
converge.
something over x squared. it's gonna
So
How do you know that, Ellen?
this
converge. I've
graph
seen it before.
from 2 to infinity. So even though the upper limit of integration is infinity, it has a finite area.
So what does that function look? I'm gonna put it.
Well,
So it is.
just do 1 over x squared. It's going to have the same end behavior.
That's what Adam
One over x?
Well, you can graph it. You guys should be able to graph this by hand.
Space it.
It actually.
I'm looking at the next one.
As a,
You
Pull up
use the
Desmos right now, bro?
parabolic
yeah, as
function.
an absolute at 0.
Of course it does.
Actually, no.
By the way, I hate your econ classes.
Yeah, what's up?
Oh, I-
What do you want me to do? No, because we don't do that in Calc. They won't give you credit for solving something of a different method. So even if you know more advanced methods, you still have to use Calc 2 methods.
That's what- yeah.
Wait, so This is the last chapter in the unit.
Why is it called a unit?
So when's our test?
Do you have a paper that closes it?
It's a surprise, Jack.
Is it this week?
Okay,
It's actually
x e to the negative x. How do we integrate that?
Split it.
Integration by parts.
Integration by parts or tabular?
Integration.
Tabular is much preferred.
Probably
Tabular.
tabular.
I forgot about tabular.
It's been like 2 weeks.
I'm going to use x and e to the negative x.
That's exactly what I did.
So 1, 0, negative e to the x. Negative e to the negative x, and then e to the negative x
Then we draw the line and
plus minus.
That's what I got.
So negative.
So it's negative x e to the negative x.
minus c.
What's wrong?
How is it a minus c? Is tabulus always minus?
Plus minus plus minus.
Well, you know it's plus
Tabulus
minus,
plus
plus
minus.
minus, plus minus, plus minus, plus minus.
Exactly.
Más y menos.
Okay.
Yeah.
All right, so now we can either do some algebra and then evaluate it or evaluate it.
It's just evaluate it.
Okay, I'm going to do a little algebra first.
Yeah. Let's do that.
So I'm going to take e to the negative x. Yeah, so I'm left with this.
Good use of factoring this table.
I would agree with that.
When did we learn factor? I think I missed that.
Algebra 1. Miss Renthorpe.
Miss Runslow? God, what kind of teachers do you have?
She got fired for being terrible.
No, she
I
got fired.
Mr. Shamanara, baby. I would hate to know about
What
that.
about Mr.
She got fired because she wasn't vaxxed.
Yeah, she refused to get vaccinated during.
Dude, what a sweetheart, actually.
She
That's
made us-
lucky blessed.
She made us pray to a triangle every week.
We learned that.
So remember yesterday, e to a power grows faster than a linear function. So now we get to incorporate what we did yesterday.
Why
So-
does, when you multiply by even the negative x, why does the. You know what? Never mind. I'm done.
Yeah, seriously.
Oh, shush.
Thank God.
Okay, so this converges.
You write QED under that, please?
Go for it.
Oh, so
You
if
can.
there's the variables are b on both top and bottom, you see what the rate of each one is.
Yes, yes.
Okay.
So now we can apply anything that we did previously. We don't have to go through and do L'Hopital's rule. We can just assume that that's going to go to 0. Okay.
Oh, really?
So now we have from negative infinity to infinity.
Oh, and that's accepted on the AP test. Just if we just prove that
Oh,
we
yeah,
understand
for
that it goes to 0, we have to apply the rule.
I made it
Pi over 2.
I made the integral from a to 0.
So we'll make it from a approaching negative infinity from a to 0.
So I got pi.
Dude, I don't mind.
You're spoiling it.
I'm
Why'd
Just
you
can you control
spoil it? That's so rude. Why'd you ruin it?
Can you control this guy? Bro, he needs to be like caged.
Wait, was he a leash kid? Did you need to have a
Oh,
leash
he's
on him? When
Was he a
was
helmet kid?
Okay. No.
You had to confirm that.
Was he a
You thought about it for a second?
Was he a helmet kid in the wild?
Were you?
Adam was.
I think Adam was definitely.
I was more of a
You know,
leash
Adam
kid.
one time came over to my house. I told him.
You love this story.
Yeah, I do.
You love this story. No computers.
Wait, tell it.
Now what?
Now it's going to be.
So tangent inverse of 0 minus tangent inverse of a.
Curveball.
Wait, what?
Because tangent inverse of infinity is.
Yeah,
pi over
isn't
2.
tangent inverse of infinity like not enough?
So tangent inverse. So what does tangent look like? Tangent has,
It has multiple asymptotes, and it kind of.
right, so here's tangent. So then tangent inverse, is going to have, right?
Wait, tangent inverse, wouldn't that go to 0?
No, little pi over 2.
Oh, yeah.
So it goes like this and this. This is tangent inverse.
Can't be greater
So this is pi over 2, and this is negative pi over 2. Right? Okay. So this first part is going to be 0 minus negative pi over 2 plus pi over 2 minus 0. Right? So as we approach negative infinity of tangent inverse, it's approaching this horizontal asymptote of negative pi over 2. As we approach positive infinity, it approaches pi over 2. So we have pi over 2 plus pi over 2.
Which is
Pi.
Oh, would not expect that to converge.
I remember this case of saying, Adam, do you think this is supposed to converge or diverge?
No, but I'm sure that the class could have put that anyways.
I'd like
I said
to
earlier.
place bets.
Converges?
Yeah.
Does any, in this case, does
That's like
anything over x
probability
squared
as well.
converge?
Does what?
Does anything
Diverging
over
is-
x squared
is plus
converge?
Not anything.
Is it like X?
Any constant over x squared.
Because I genuinely, oh, are we done with that? No, okay, I'm sorry.
Anything a constant over x squared will converge.
What about over x?
Wait, are we doing this first?
Anything that has a power greater than 1, which we will learn again, series. Something called a p-series. Okay. Okay, this was the other thing someone was asking about. These are not the only type of improper integrals. We can also have vertical asymptotes, right? So take, for example, 1 over root x. There's a vertical asymptote at 0. But that doesn't mean that we can't evaluate it necessarily. So we're going to do the same thing, and we're just going to introduce a variable a, b, doesn't matter,
As we're approaching 0.
as we approach 0 from the,
Right.
good.
Why no?
Because you can't have negative.
Because we're looking at the right side of the graph.
You can't look from the left. It's not defined from the left anyway, right? You can only have,
Imaginary.
well, yeah, but the function, it's not defined for negative values.
Ooh, good one, Tyler.
Hydroplastic and so.
Ooh, still water.
Okay?
Those who know.
So you have to do it by. You
Shut
have to do
up.
one side.
Those who know.
Actually, be quiet.
Oh, yeah.
You have to do one. So you
You're
do one
looking at
side
Scott?
on it.
Yeah.
Better earning to be good.
Good.
I was thinking how big this is. Oh, I guess it's.
Okay, so we'll go down. We're good with that? Does that make sense? Why you
Yeah.
want to approach? Okay, so here, so what is the integral? That's going to be,
Negative 1/2.
It's gonna be 2
Wait, that's the wrong one.
you're going the wrong way.
1/2.
2 root X.
It's 2 root
X
I
to the
was
1
gonna go
half
the wrong
over
way.
1 half, so 2 root x.
I was going to do it the long way. I was gonna get to it.
You were going to get there eventually. 2 root x evaluated from a to 1. So what will we have?
I believe it's gonna be
We'll have 2 minus 2 root a.
Come on.
And
But we have a radical against what we do.
what?
What do we do?
Well, as a approaches 0 from the right, we get
0.
Wait, there's
2.
no.
Wait, is it?
That goes to 0.
Yeah, that's what I meant.
Oh, I thought you were talking about the
We
whole
were talking about
thing.
Well, Tyler, we were talking.
So therefore, the area under the curve from 0 to 1 is
about 2.
no. The integral already represents a limit, so it's equal to 2. It's not about 2. It is 2. We don't need an approximate sign.
So it converges at 2, or that's just the answer?
Wait, are we done?
Like, it's not a, is it a converge or diverge problem, or it's just like a nice answer?
It converges. Yeah, this converges. You could also say this converges.
Wow, that's crazy.
Yeah? I think I only have, what do we have? Oh, there's a lot.
Is there a lot more? Oh.
Wait, is this the last lesson?
What I think, okay, so this page is just more on the definition of everything. So, again, you could have, right, an asymptote on the left. This would be an asymptote on the right. This would be an asymptote on either side.
What?